Welcome to Organic Chemistry. This topic is no longer tested. So this is kind of a crazy week. According to the schedule, this is an organic chemistry week, but it's about a topic that is not on the exam any longer. I keep it in the schedule because I need you to be literate. I need you to be able to read an organic chemical's name and to understand a little bit about it. I don't need you to be fluent in organic chem. I just need you not to freak out. Okay, so what takeaways do you need to have from this week? One, organic chemicals are just normal chemicals. They follow all the rules that you will know. So when we get to the exam, if you see this chemical that it has a weird name, you've never seen it before, all you need to take with you is the fact that you can still use this chemical. You can still do a lot of math with it, even if you don't know exactly what it is. Like I said before, number two, I don't want you to freak out when you see a really long name. It's just a chemical. And then number three, I need you to stay on the lookout for two things. One is if you ever see this COOH in a name, or if you see a particle diagram or a Lewis dot structure that goes C double bond O OH, that thing is an acid. And you really need to know that. So at the end of the week, I need you to take this with you, that this COO or COOH or this COOH written like that, that's an acid, and that has to send off alarm bells for you. If you see any strange group with a nitrogen in it, so like an NH2 or an NH3, NH4, or a CH3N2, this nitrogen right here needs to send alarm bells. It is most likely a base. So we won't formally talk about acids and bases for a long time, but I need you to keep that in the back of your mind. Like certain organic chemicals give away the fact that they're acids, or they give away the fact that they are bases. This week, though, we are going to start off by looking at alkanes. They are nothing but carbons bonded to other carbons and carbons bonded to H's, where there are only single bonds involved. Now, they're given the name alkane because the ending, this ANE ending, is what telegraphs to you that it is nothing but C's and H's and single bonds. So any name that ends in an ANE is going to be C's, H's, and single bonds. The same way that if you have a hormone like testosterone or progesterone, they generally end with an ONE ending. Or take enzymes, usually end with an ASE ending. Like I'm having a hard time coming up with an enzyme right now, but they all generally end in ASE endings. So let's say I take a look at carbon here. A carbon atom, if I drew its Lewis dot structure, would be a C surrounded by 4 electrons. It has 4 electrons around its outside in the valence shell, so it's generally able to make 4 bonds. So keep that in mind. Carbon is going to bond 4 times. So let's take the simplest one carbon bonded to 4 hydrogens. That would be CH4. And you would think, well, is that thing called a carbon tetrahydride, 4 hydrogens? And the answer is no. This is an organic molecule. It's an alkane because it is nothing but carbons, hydrogens, and single bonds. So it's going to have its own naming system. So this doesn't look much like a chain. In fact, it looks more like a circle, but we're going to call them chains anyway. And if there is 1 carbon in a chain, it is called a methane. So this molecule up here is not called carbon tetrahydride. It's just called methane. If there were 2 carbons in a chain, it would be called ethane. 3 would be propane, 4 would be butane, and I lump these into weird organic prefixes. A few years ago, if you took AP Chem, I would tell you that you must memorize them. These days, it's not tested, so it's not important that you memorize them, but when you see them, you should know, oh, this is an organic chemical and it's got a small number of carbons. After you get to 4, then we start getting into prefixes that you know. Pentane is 5, hexane is 6, octane is 8, decane is 10, just like polygons. If you had a 6-sided object, you have a hexagon. And if you have an 8-sided object, you have an octagon. So the names are the same as the polygon prefixes. Nothing special there. Okay. What if a carbon is not a part of the main chain? Then it's called a branch. So if a carbon takes off in its own kind of direction, it'll be a branch, and we will count up the number of carbons in a branch, and they will be almost the same as before, but we'll give away the fact that it is part of a branch with a YL ending. So if a branch has 1 carbon, it's part of a methyl group. 2 carbons is an ethyl, 3 is a propyl, and 4 is a butyl group. And if you have branches, we need to know where those branches occur. So just like your house needs an address so that we know where to send the mail, a branch needs an address so we know where it is connected. There are some rules about that. Your branch should be numbered so that it has the lowest possible number on the main chain. Now, it sounds a little confusing, but imagine that your street, all of the houses, no matter what street you lived on, always started with 1 and went to the highest number. So if you were at the end of the street, you would always be a 1 or the highest number. And if a house branched off of your street, it would be given the lowest possible address that you could. If a main chain has more than 1 branch, then the branches are numbered, but they are listed alphabetically. And I'm going to do some examples of that, and we'll see what I mean by that soon. So I'm going to go through some examples here. There's some rules up here. Identify the number of carbons in the longest continuous chain. So that's going to be our first thing. Then we want to identify any branches and find out how long they are. And then we are going to come up with a numbering system so that we can figure out the addresses. So we already did number 1. This is methane. And over here, we have 2 carbons in a chain. So if I were to highlight this thing, that is a 2-carbon chain, carbon 1, carbon 2, and a 2-carbon chain is an eth. But it's only carbons and hydrogens, and there are no branches. Everything is part of the main chain, so this is an ethane. Ethane. This one, 3 carbons. What's the name of that? It's a propyl or propane, sorry, since it's part of the main chain. And then here we have propane again, but the chain is bent. Does it matter that the chain is bent? No. All you do is you identify the longest possible chain that you can make without breaking it. So in this case, the fact that it makes a 90-degree turn does not matter. That is still one continuous chain with 1, 2, 3 carbons. So it is a propane, even though it's got a bend in it. Down here, we've got a chain. It's got 4 carbons. So this is a butane. And then take a look at number 6 for a second. What molecule is this? It looks like it's got 3 carbons in a chain and a branch coming off here, but that is not correct. I can make one continuous chain without breaking that has 4 carbons in it. And a 4-carbon chain is the same as this 4-carbon chain, just with a turn. So this is also a butane. Chemists don't care about the bends. They're unimportant. Now here in number 7, we come up with an interesting issue. Where's the longest chain? Take a second and think about that. Did you draw this as your longest chain? It has 1, 2, 3 carbons in it. And this carbon over here is excluded because I would have had to like double back on myself to get it. So it's not part of the main chain. It's actually going to be a branch. Now, if you didn't draw that as your main chain, stay tuned. I'm going to talk about that. But for now, let's take my main chain and figure out how to name it. So the main chain here is a 3-carbon chain. So it's a propane as the main chain. And our branch is a 1-carbon chain. So it is a methyl. So we need an address for this thing, and the address is that it is connected to number 2. So the way that you write the name for this is 2-methyl propane. 2-methyl propane. Now wait a minute. What if you actually wrote it this way? I'm going to ignore the hydrogens for a second. What if you made your main chain this main chain? Your longest chain is still a propane. You still have a branch with 1 carbon, and it's still at carbon number 2. So its name is still 2-methyl propane. The name doesn't change. So it honestly doesn't matter what you pick as your longest chain, as long as, in fact, it is your longest chain. Let's take a look at a couple more examples. Let's take a look at this one up here. And pause the video and see if you can come up with a name for this thing. Okay, I'm going to say that my longest chain is this one. Is that the only possible longest chain? And the answer is no. I could have made this my longest chain. But I'm going to submit to you that it actually does not matter which one we pick, that the name will be the same. So in this case, our longest possible chain is 4 carbons. 1, 2, 3, 4. Okay, and so I've got a butane, and I've got 1 carbon as the branch, and it's located on carbon number 2. So this again will be a 2-methyl, because the methyl group or the methyl branch comes off of carbon 2, and we've got 4 carbons, so it is a butane. 2-methyl butane. Now, some people are going to say, well, wait a minute, like I started at the bottom and worked my way to the top. So let's cross out some things here, and I'm going to renumber. I'm going to make this carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So isn't this really a 3-methyl butane? And the answer is no, because remember the rule that when you draw out your chain, your branch should have the smallest possible address. And a 2-methyl is a smaller address than a 3-methyl. So in this case, it would be proper to name it as 2 rather than 3-methyl. Take a look at number 11. Our longest chain is 4 carbons. So it's going to wind up being some kind of butane. And it looks pretty obvious that this is 1, 2, 3. So we should do a 3 with a 1-branched methyl. So it should be 3-methyl butane, right? No. In fact, If we numbered from the other direction and I went 1, 2, that actually, this would turn out to be a 2-methylbutane. So make sure that you're always paying attention to the addresses and seeing which ones are possible and give you the smallest number. Okay, last example here. This one seems pretty obvious. We should take that as our main chain. We could have done a main chain that came from the top and bent over, or a main chain that came from the bottom and bent to the right. Either one of these would be fine, and they will give you the same answer. I'm going to choose this chain, though, because it's probably the simplest possible way to look at it. So I number my carbons, and I've got a butane as my backbone or my main chain. But now I have two separate branches. I've got a branch that goes up and a branch that goes down. So I'm going to have two branches, but they're both methyl branches. And to be even weirder than that, they are both on the second carbon. So when I write the name for this thing, I'm going to say that it is 2, 2, because both branches occur on carbon 2. And it is a dimethyl. And it's dimethyl because there are 2 methyl groups. If I had 3 methyl groups attached there, which is actually not possible, but let's say I did, it would be a trimethyl. You get the pattern there, I hope. So it is a 2,2-dimethyl butane because the main chain is still a 4-carbon chain. Okay, last thing here. What is this molecule called? It's got a 4-carbon chain and it has a 1-carbon branch. So this thing will be called 1,2,2-methyl because it's a 1-carbon branch, butane because the main chain has 4 carbons in it. What's number 2 called? And I hope you recognize that you can't answer, because so far we've learned about alkanes, and alkanes are only allowed to have carbons and hydrogens, which this one does, but only single bonds. That is a double bond, and we will talk about those in a future video. We can't name this one either because it actually includes a chlorine, which means it's no longer an alkane. It has a halogen group, which has a separate naming system. This one we can't name either because it's got this crazy cyclical thing there. It's actually trying to tell us that the carbons are attached in a hexagon. And because it's in this cycle, we're going to learn to name those later. Plus, it's got these NO2 groups that also make it impossible for us to name. Here, number 5, we've got both a cyclical ring and a chlorine. We're not going to name that in this video. So what I need you to take away, alkanes end in ane. They only have single bonds, C's and H's. And if you see a double bond or a triple bond, I forgot to mention that triple bond there, then you can't name it yet, and you'll have to watch our next video.